day 2 practical session supposed to be, because we don't have time. We are carrying it forward today. We have another 50 minutes. Okay, so we're going to look at how EMG device, remember electromyography, how are we going to use that to collect some data and how those data can be useful. Okay, EMG data, is it kinetic data or kinematic data? EMG data, what is kinetic and kinematic? Kinematic and kinetic. Kinematic involve measurement caused by your movement. Angle. Remember the day I said you have measured what? What did you measure? Knee angle, hip angle, ankle angle, time, distance, stride length, stride frequency. Anything you can measure by looking through the video. Kinetic. Kinematic is what caused that movement. Like my muscle force. Force, can you see? Can you measure with your camera? You need a special device to measure. So it's called kinetic. Okay? No, now EMG, we're going to measure the activation of the muscle. So it's kinetic or kinematic? Again, kinematic is something that we measure from the movement that you're measuring. What movement? The day we measure when someone is walking here, knee angle. We are measuring directly knee angle. That's kinematic. Okay? Height of the jump. Kinematic. Step length. Stride frequency. Kinematics, everything. But what caused that movement? Internally, what caused that movement is called as kinetic. Whatever, it can be force, it can be joint loading, it can be anything internally happening, is called as kinetic. Movement, kinematic. What caused that movement? Kinetic. Clear? Okay, when I walk, there are certain amount of torque, load in my knee. Kinetic or kinematic? Kinetic, because it caused my movement. It caused my movement. Okay, clear? This is going to be one of the questions for tomorrow. I think I already give 5 or 6 questions, right? Total 50 questions. 50. Passing rate is about 40. So I'll make 30 very simple, straightforward. Another 10 moderate. All multiple choices. Another 10 a bit difficult. Difficult means that what is kinetic? Choose one of the non-kinetic parameter from ABCD. That's all. Okay? If you all stayed with me from day 1, you can get 50 over 50. If you all played with your phone, if you all playing games when I'm teaching here, maybe 40. Okay, now we're going to look into EMG. Okay, the function of EMG is to measure the muscle activation signal. Okay, muscle performance signals. Muscle, they will when it's activating, they'll give a certain electrical signals which can be measured using electromyography device. So the experiment that we're going to do today is someone going to walk the power adapter. Gaurav. Okay, we have one of the participants which will walk. We're going to place EMG on which 3 muscles, right? Each VMO, VLO and their tibialis anterior, left and right. So what do we want to see? Mostly EMG will help us to understand the sequence of muscle activation. Remember when we say when we are walking, This muscle should be activated before this muscle during each walking gait phase. We're going to see that in real. Is it happening or not? Okay. So there are certain procedures for EMG preparation. There are certain procedures, clinical procedures. Anyone has used EMG before? EMG, okay. You can come and explain the procedure. Yeah. Okay. We use EMG mostly for athletes who we suspect that they have one side muscle is not signaling as having signal as another side of the muscle. Okay.
Which one you want me to explain? Surface EMG? Surface EMG. So I'm Dr. Purushottam. I'm working in the neurophysiotherapy. Almost 20 years onwards, I'm using surface EMG for my patients, analyzing their muscle performance. Sir has asked me to explain the procedure, how you do it. First, you select the muscle which you want to assess it. For example, if you are taking for biceps, you select the biceps muscle. Okay. You clean it so that we use it for reducing the resistance. The electrodes, what you place, we call that sensors. So you identify the correct motor point or the muscle, the where you keep that electrodes. Like sir is suggesting, we keep it belly tendon system. You remember the formula, easy to get it. This if you think that this is a belly where the maximum bulk is, then tendon for that biceps is bottom. So you keep it between origin and insertion, center spot you take away, the belly, that would be the electrode placement. Then after placing the electrodes,
Just show them how to choose these three muscles we mentioned.
okay. Now I mentioned about biceps.
No, we're going to put
Okay.
VMO, VLO, and
Okay. Sir has asked about VMO to look for vastus medialis obliquus. Vastus medialis obliquus. So we need to check first testing. We can't give directly the application. What we do, knee extension with that, ankle dorsiflexion with that, some rotation to do it. We get exactly VMO activation. So following the VM activation, for example, I got activation at this spot. Now you see this. The quadriceps origin is here, incision here, center spot here. Otherwise, what you do, for several people I tell you, divide this into three parts. Upper one third, middle one third, lower one third. Three segments to take it. Take the middle one third segment. You keep your sensors. One you have an active electrode, other one is inactive. Otherwise, you remember one cathode, one anode. We use that. Otherwise, remember one positive or otherwise negative electrodes.
we don't have that. So only single.
Okay, then you have here, you place exactly over the middle one third of the quadriceps.
So there are three. You have identified the three muscles: V vastus medialis, vastus lateralis, and tibialis anterior.
Tibialis anterior.
So in the software, we have already paired the first sensor with VMO, right? Right VMO. Sometimes, suppose the muscles are not very visible, tell him to contract madi, tight madi. Hello, face them. Now we can see this muscle,
clearly
right?
you can see.
VMO you can see. So in del sys, you have to align this arrow with the muscle fiber. Okay. So this is a double-sided sticker, especially for where these sensors are exposed. So the one side you stick to this, other side comes on there. So you just remove this. And process. This one, especially middle of the belly of this muscle, that is medialis.
Okay, usually before this process, we will have another process called skin preparation. Okay, we will have one process called skin preparation. We are skipping that because the process involved in skin preparation is you need to shave the hair. And then we need to use sandpaper to make sure that the surface where we are collecting data,
The resistance is
the residual are free. Okay, so in clinical point of view, we were taught that you need to clean it. You know, multimeter, you can measure the ohms, the ohms. So you need to be below 5 milliohms. 10 is still okay, but the best is
Kilovolt, kilo ohms.
kilo ohms. No,
So the resistance is measured in the ohms.
The-
You want to bring that to usually I take that close to the 2000 ohms. If you bring it, is easy for the sensors to capture
Yeah.
the potentials.
If not, there'll be some interference. But for this sensor, in this case, because we are just doing trial, we are avoiding skipping that step. But it's very important to do that step, skin preparation. You can always go and search for skin preparation for EMG analysis. Okay? And then you test with multimeter. When you have enough within the range, the muscle is ready to be placed with electrodes. These electrodes will be placed at the belly of the muscle during high activation. Okay, and then there are a lot of sensors. What is that? Brands available. We use Norexon back in Malaysia, but here we are using Delsys. Everything going to give you the same kind of input. It's just different brands. Maybe the dashboard will be different.
That once the preparation, you want that how interpretation of that.
Challenges that you face. Any challenges you face?
Challenges what we face is like securing loose contact, sweat, and the close proximity. Now this electrode has got advantage. Both active inactive electrodes are fixed mounted in that, so that challenge is already overcome with this. What I use the button sensors, so that moves. Yeah. Otherwise, now you have a technology, the single-use adhesive tape, so that you don't have to spread the infections. Those challenges are overcome now with this technology now. I think this is all wireless free, so that is also the challenge also overcome. You can move around. I think it may pick around 50 to 60 meters the potentials.
The range it can 40 meters.
So that's what's with the Wi-Fi, it can pick it.
So most common challenge that we face is when they get sweat, it will tend to come out. So there's a glue called skin glue, specifically for EMG. It's in the market. Okay, so they call skin glue, very small. You can break the lid and then you can apply it with cotton bud. Okay, you can buy that and you can use that to overcome those challenges. Any other challenges? Mostly with technology nowadays, like Sir mentioned, they already solved the...
Because now no wires and no straps. Now if you apply, usually I apply straps and then look for that wires. Now it's a wireless and then strapless, so that it's very easy to gather the data. Most of the challenges are overcome with this. This is, I think, applying the... That's all, sir. Thank you.
Thank you so much. Okay, any questions for preparation before we go into data collection? You all see that, how preparation, you need to know how to find the muscle, right muscle. Why did we choose these three instead of other muscles? Why did we choose these three? So because when walking and running, those are the muscles highly contribute. Okay, even though glute muscle, they have a lot of layers which won't give you the right signal when you use gluteus maximus. Okay, so we stick to these three muscles which highly contribute when walking or running in different phases, different events. Remember, we talk about walking and running gait. So that is how you prepare. So now they're going to... so before you know how many percentage that muscle is activating, if you want to tell that, okay, if I'm carrying a 5 kilogram, if I'm carrying a 5 kilogram dumbbell, it shows that 10 milliohms. If I'm carrying a 5 kilogram dumbbell, it's showing 5. What is my maximum? How will you say the 5 is? How many percentage from my maximum? You all do 1 RM test, right? For strength test. Similar concept apply for when you're doing EMG. Okay, we call that MVC. What is that MVC? Maximum voluntary contraction. Isometric contractions. You need to know the capacity of that muscle. If you push it to the maximum level, what is the signal produced? Example, if it produces 100 and when he's walking is activated 20, how do you report it? Activated 20 percentage. If I,
averages, like which
no, I'm explaining about MVC and muscle activation. Later, there are a lot of parameters. You can use RMS values. You can normalize to the maximum MVC. We usually normalize to MVC. We don't use RMS. Even though the data that they give, we can have like hundreds of data there you can get. Okay. So we'll see percentage of left. Okay. Now, if I want to say that like when he's walking, he's using X amount of muscle activation, should I collect MVC here and here or only one side? Can I assume his left and right are equal? So I only collect one side. I cannot do that. I must collect for all these three. So there are protocols, certain protocols, inbuilt protocols within the system. They will teach you how to do MVC test, maximum voluntary contraction test. So at which action, in which action, what action can cause that muscle to contract maximally? You want to know the isometric contraction. Okay, so for VMO, what are the tests we're going to do for MVC? There's a machine there. Okay, so let him do leg extension and so we'll collect the MVC. Okay? Understand why we are doing this? We want to get the reading of his maximum voluntary contraction. So that later when he's walking, we have something to compare to. When he's walking, he used 10, then we know if his maximum is 100, that it activated by 10 percentage. How to? I cannot hear you.
How to reduce crosstalk between the muscle?
Cross what?
Crosstalk.
I don't know what is that.
There was a battery, paperized, there will be some challenges when we do the muscle crosstalk also. Like sometimes they tend to pick up the activation not when we have reached the
Oh, like this walkie-talkie signal come from different frequency. Usually we have never had this issue because we place exactly, we know where to place. If you put in that muscle, that's why we put at the belly and not at the insertion or origin of the muscle. So that it will be away from the next muscle. Away from the next muscle. So if there's, and then during test you will know. When you're testing, if you have signal there and both must signal, if it's very close to each other, it's going to be challenging, like you said. If this muscle and this muscle is very close to each other, there are chances. So we'll try to avoid that kind of situation usually. But we never experience. So how do they overcome that? You all can go there and see how they are conducting MVC.
Okay, right. Actually, there are different protocols. For example, they take 5-second contraction. He should not be able to lift it. It is maximum voluntary isometric contraction. So the resistance should be maximum. He should not be able to move it. Right. So sometimes they do 5 seconds, 30 seconds gap into 3. Then they take the average of that. But this is built into the system. Even in the system, we can change the parameters, but we'll go with that. In that, there is 3 seconds, 5 seconds gap, 8 seconds gap, 3 seconds into 3. So I will give him the, what is that, the cues. Start, stop, start, stop. So for each muscle, we have to do MVC. So now there are 6 muscles we are testing. So 6 MVCs we have to do. It will get recorded. Okay? Sujendra, ready?
Well, you can go there and see if you are interested to know how they are doing the MVC.
This thing you can see on the screen. Sujendra, ready ಆಗು. Start ಹೇಳುವಾಗ ಆಯ್ತಾ? For 3 seconds. Only the right leg first. Ready? 4. Left leg, sorry. Ready? Left leg. 2, 1, go.
Go,
Stop.
push. Harder,
Stop,
push.
stop,
Go on.
stop.
So you need to, when you're doing data collection, you need to do this to get because what are we trying to get here? The best out of him. If everyone quiet, he'll go to sleep. So when we collect MVC, we'll make sure that we really pump him up to get the best out of him. See, just now he cannot move. After I scream, he'll start to move. You must do 100%. That done, sir?
No, sir. We will require. Sir, it is just for 3 seconds according to this.
Okay.
1 second. I'll just cancel this thing. Okay. 3 seconds. When I say start, maximum, end. Okay. Stop. You have to stop.
Left or right?
Left leg.
Left leg.
Left LVMO. 6.
Single leg, huh? Left leg. Only.
Okay. Ready? See the countdown. 3,
That leg put
2, 1, go.
Go, push. Only left. Go.
Stop. Okay, ready? 5, 4, 3, 2, 1, go.
Left leg. Go. Push. Harder. Come on. So no recovery in between.
4, recovery now. 1, go.
Come on, I want to see it moving. Come on. Push harder. Push.
Stop.
Go.
Stop. Yeah. ಸುಜೇಂದ್ರ ಲೆಫ್ಟ್ ಲೆಗ್ ಮಾಡ್ತಾ ಇದೆಯಾ ಅಲ್ವಾ? ಓಕೆ ಅಲ್ಲ ಒಂದು ಬಂತು ಬಿಡಿ, ಜಸ್ಟ್ ಡಿಮೋ ಅಲ್ಲ. ಓಕೆ, ಸೊ ಐ ವಿಲ್ ಸೇವ್ ದಿಸ್ ಕ್ಯಾಲಿಬ್ರೇಷನ್. I will save it.
Try to take one leg out so that you don't activate that.
Okay. Now again the left leg will do for this was the vastus medialis muscle. Since the quadriceps are extensed, so the same exercise we'll do for the vastus lateralis muscle. Sujendra, same left leg.
Loudly speak.
Same. Sujendra, left leg aita. Same. Okay, ready? 4, 3, 2, 1, go.
Yes, push harder. I want to see it moving.
Stop.
Push harder.
Stop, yeah. Relax. Only 3 seconds. Ready? Go. 2, 1. Stop. Only 3 seconds. 4, 3, 2, 1. Go.
Harder. I want to see it moving. Harder.
Stop. Hey, Michael, the
arousal level to high to get the best.
So the left medialis is left lateralis is over.
Mohita.
One lady come.
So same calibration. Let's go. So now the right side. Now we go for the right side. Right vastus medialis. Calibrate. MBC. Right. Begin. Save.
Ready, yeah?
You got it.
Because what I tell him not to shout in the mic. What I say, he's not getting. Ready? Okay, 4, right side, 3, 2, 1, go. Go, 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 go. Push, 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 go, go. Stop, stop. 3 seconds. Tell not to use the mic.
Scary.
Ready? 2,
Let's go.
1, go. Go, go, go. Push, 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 push. Go, 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 go. Stop, stop, stop. Last one. 4, 3, 2, 1, go. Go, 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 go. Stop, stop, stop.
Okay, next one.
So much you're shouting.
Yeah.
You keep it with you.
Come on, ladies, go.
You hold it.
Go, sir. Yeah.
Now the same exercise, right leg for the last lateralis muscle. We are low. One minute.
Should he rest first, sir? Should he rest or continue straight?
Let him rest for a minute.
Okay.
See, normally we have to give a minute or two rest, but for the purpose of speeding up things, we are maybe. So it takes at least half an hour for a person to get tested, and in case it gets loose again, we have to repeat the whole process. So it's not that once you change the position of the sensors, then again you have to do it again, because again the position has changed. So now second, right leg once again. Okay, please don't shout in the mic because he can't hear my cueing. So ready? 4, 3, 2, 1, start.
Good, good, good. Little harder. Good going, good.
Stop. Ready? 5, 4, 3, 2, 1, go.
Come on, little harder. Yeah, come on, good going.
Last one. 5, 4, 3, 2, 1, go.
Good trying. Little harder. Good.
Stop. Okay, relax. You can relax and come here.
How about his tibialis?
Yeah. Can you do against the hand resistance?
This one. You don't have any leg press?
No, not for calf. He has to do this dorsal flexion.
You don't have anything for that?
No, we can put the hand resistance.
Yeah,
You can long sitting position.
They don't have protocol. Do they have protocol there? What test to do for which muscle?
Those are not there. Those we only have to devise. We
It's
only
not
have
there.
to, it's not the tests are not there. Only the
I think it should be there.
testing protocol is there.
If you choose the muscle, they'll tell how to do that.
No, that is not there. That is not there. Yeah. Muscles are not there. Anyway, long sitting ali ಕೂತ್ಕೊ.
But
He's sitting in a long sitting position.
so I think we don't have enough time.
No, just
until
two.
1 o'clock we collect. After they come back, we
No,
do.
just two. This. That's all. Just two. Only
No,
2 minutes. will
Later
take.
he need to run.
Yeah. No, for this it
Take
takes
video.
only-
No, this
two
one we do
muscles.
now.
Yeah, okay.
After that, the
Okay.
data interpretation. later.
Right. Okay, now one more thing. See, there are a lot of reference materials which tell you how to do the MVC, which are the exact tests for MVC. And for example, in leg extension, if you come from this position, you won't be able to activate here. So almost somewhere from here, you should be able to give the isometric. Right. So from which angle you have to start. Right now. We are doing it for our sakes. Now the tibialis anterior muscle helps in dorsal flexion, right? So we are going to give him manual resistance, and he has to try to do the dorsal flexion, right? In this position, straighten. Okay, this is a neutral position. Now they'll give this. He has to in the press. ಹಿಂದೆ ಹೀಗೆ ಹಿಂದೆ ಹೇಳ್ಬೇಕು ಹಿಂದೆ ಹೇಳಿ. Okay, right? He has to press against the hand. Correct, no? That's okay. So this is for our purpose we are doing right now. So if you want to, when you're doing research, you can go to the references and see exactly what is the perfect test. But first now this is for the right leg. We are choosing the right. Calibrate, MVC, begin, save. Okay. Okay, now we have started this. Now it is taking time to, it's loading. You can see on the screen. You can see on the screen. Okay, ready? 4, 3, 2, 1, go. Come on. Stop. Again. 4, 3, 2, 1, go. Stop. Last one. Straight, yes. Ready? 2, 1, go. Come on, come on. Still more. Pull. Yes, relax. ಅವ್ರು ಜಾಸ್ತಿ ಹೀಗೆ ಮಾಡಿದ್ರೆ ಪವರ್ ಸಿಗೋದಿಲ್ಲ, ಸ್ವಲ್ಪ ಹೀಗೆ ಇರಲಿ. ಫ್ರಮ್ ದಿಸ್ ಪೊಸಿಷನ್ ಪುಲ್ ಮಾಡಿ. ಈಗ ಇಲ್ಲಿ ಇಡಿ ಅಷ್ಟೇ. ಟಿಪ್ ಪುಲ್ ಮಾಡು. ನೀನು ಎಳಿಬೇಡ, ನೀನು ಎಳಿಬಾರ್ದು, ಅವ್ನು ಬಿಡಬಾರ್ದು ಅಷ್ಟೇ. ಓಕೆ, he should not pull it back. He should just give him resistance. These are small muscles, he can't. Okay. So I have saved that calibration. Save. Fine. So you can see on the right side of the screen for all the muscles we have got both. One is EMG, raw data, and one is calibrated data. So one more muscle is left. Okay, one second. This RTA. Oh, this should have been okay. Fine. Okay, now last one. Okay, this should be actually okay. Fine, this okay. We did some mistake here. Okay, RTA. This is 3, no? Okay. Oh, this is right. Okay, we'll put this as right only. Okay, we did a small mistake. See, that's what that is some of the challenges. We put both the labels as RTA and RTA. So right, actually the sensor which we put for the right, for actually we put for the left. We'll do it, repeat it again once again. We'll just cancel this calibrate. It's already been okay. It's fine. Just for the sake of this. Now the RTA. Now the right leg. Fine. Okay. There's a small mistake, and now we have to. Since we have already done that, we have to off it and on it again. Let's avoid that. Just for this, for the sake of demo. So we'll do the thing that is the left TA, left tibialis anterior. Almost same it will be, but of course don't do it in research. But now we'll do for the right. Restart. Okay. Okay, so see, when we did this, actually for LTA, the sensor is LTA, but then we did it for RTA because I wrote that RTA. So if you see here, calibration, I can't change it now. So I have to, calibrations are saved. So I go back, again I restart this, Trigno. ಇಲ್ಲ calibration save ಆಗುತ್ತೆ. ನಿನ್ನ ಮೊನ್ನೆ ಮಾಡಿದ್ದು save ಆಗುತ್ತೆ. Then you have to choose. In these calibrations, calibrations are saved. You can do today, tomorrow, day after, but all the dates will be coming. So when you want to pair it for the raw, then you have to select which calibration you want, which day you did. So again, sensors are being scanned. Because we put the sensor 1, 2, 3 on the right side, 4, 5, 6 on the left side. So 3 and 6 is tibialis anterior. Okay, so the sensor here, there is 4. 4 is left. Okay, we'll do the right again. It will take around 10 seconds, 10, 15 seconds to load. Right side. Okay, ready? 5, 4, 3, 2, 1, go. Come on, come on. Yes, stop. 5, 4, 3, 2, 1, go. Yes, relax. Fully relax. Okay. 5, 4, 3, 2, 1, go. Yes, relax. So we save this calibration. Save. So then the last one is the fourth LTA. You can see there. So calibrate. Now you can see that the previous calibration is there. We can delete it. Just select that and delete that. So not to be confused. Okay, we'll do a new calibration. Begin. Save. Play. So 3, 2, 1, go. Left. Yes. I said relax. It's okay, okay. I said left, no. Okay, ready? Go. Come on, come on. Relax. 5, 4, 3, 2, 1, go. Yes. Relax. So all the muscles MVC has been done. So it is internally recorded, right? So next time when he's doing any performance, it will be compared to that and your percentage will come automatically. So this is actually the latest software which Delsys has done. So we save this calibration, save it. See, one more thing I just want to show you. Suppose if we calibrate like this, okay? Already, okay. We can go for the settings because we already done. This one, no? So previous we had calibrated, but it hasn't loaded. We load it into the trials, so it's loaded. So this one, we go to calibrate. See, the previous have we done a 19.8 yesterday, day before yesterday we had just tested. So take 22 today's, apply. So it is coming here. So even this one, calibrate, apply, calibrate, apply. LVMO. Okay, so all these are paired. You can see on the right side. So this is the plot configuration. See, all these 6 sensors are there, and EMG1 and EMG calibrated for each of this. Now, it's simple thing. We have to play, right? Everything has been done. All preliminaries have been done. Now, whatever exercise we want to do, we'll do. Get up, get up. So
we will collect data, walking data and running, and then we will be processing. You all can go for lunch. Later when we come back, we can look at the process
Gaurav.
data. Okay?
Gaurav, on ಮಾಡು on ಮಾಡು. ಅಲ್ಲ ಇದು ಟ್ರೆಡ್ಮಿಲ್ ಸೊ ಮೊನ್ನೆ ಎಷ್ಟರಲ್ಲಿ ವಾಕ್ ಓಕೆ ಅರೌಂಡ್ 5 ಮಾಡು 5 ಸ್ಪೀಡ್
It's on.
ಸ್ಟಾರ್ಟ್
It's not on. Is it on?
ಅಲ್ಲ ನೋಡು ಓಕೆ
So he needs some time to familiarize. Let him walk from a minute to before you collect the data. He need to get used.
4 ಅಲ್ಲಿ ಮಾಡಿ ಆರಾಮ್ಸೆ ವಾಕ್ ಮಾಡ್ಬಾ Arun, ಅಭ್ಯಾಸ ಇಲ್ವಾ?
No, no. So the electrode placement, you need to make sure you have a proper mechanism to overcome that. Okay.
Sir, we'll put a tape just for this. Otherwise, it will be a problem. Four. ನಾ ಹೇಳ್ತೇನೆ ಹಾಕೆಲ್ಲದಕ್ಕ ರೌಂಡ್ ಹಾಕೊಂಡು ಫುಲ್ ರೌಂಡ್ ಕೊಡು ಸ್ಟಿಕ್ಕರ್ ಏನಿಲ್ಲ
We usually will try to avoid putting this tape because there will be some artifact signals because of the compression. Okay, the best is to have skin glue. You use the skin glue for EMG. That specifically they are selling for EMG placement. Put and then it won't come out. Okay.
ವಾಕ್ ಮಾಡಿ ಬರಲ್ವಾ ಮತ್ತೆ ಇವ ಟ್ರೆಡ್ಮಿಲ್ ಎಂತ ವಾಕ್ ಮಾಡ್ತಾನೆ ಒಂದು ನಿಮಿಷ ವೆಯ್ಟ್ ನಿಲ್ಲು ವಾಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಅವೆಲ್ಲ ಅಭ್ಯಾಸ ಇದೆ ಅಂತ ಹೇಳಿದ ಸರಿ ನಡೆಯು ಆರಾಮ್ಸೆ ಮಾರ್ಕೆಟ್ ಅಲ್ಲಿ ಹೇಗೆ ವಾಕ್ ಮಾಡೋದು ಹಾಗೆ ಮಾಡು ಹಾಗೆ ವಾಕ್ ಹೀಗೆ ಹೀಗೆ ಮೇಲೆ ಬಿಡಬೇಡ ಆರಾಮ್ಸೆ ಕಾಲು ಹೊತ್ತಿಗೆ ಕಾಲು ಹತ್ತಿರ ನೀವೇ ಬೆಂಡ್ ಮಾಡಲ್ಲ ಬಿಡಿ ಮೆಲ್ಲ ಇರಲಿ Okay, this is one problem because we have to familiarize this person. He said he knows all these treadmills, so and he's an athlete actually. So I thought take it for granted he knows. So it's better we 2-3 days before we familiarize so that it becomes second nature to them, right? So anyway, now for us, our demo is to get the data. So we'll get the data. We'll see what wrong he's doing or. Okay, so I'll start.
The screen is.
See, now he is almost familiarized.
Can we see the screen? See that screen.
One second. Hey, you want to carry Ajay? Ajay? Okay. Hey, Ajay. Ajay. Ajay, मैं फोन मारू ಯಾಕೆ ಇದೆಂತ
Is it his normal walking style? This is not his normal walking it, right? You can see from observation itself. So I will give them break. It's already 1 o'clock.
Yeah.
We continue after. Okay. We collect data. Okay. We will continue to collect, but later data presentation we will do after lunch. So you all can go for lunch now. Whoever want to stay and see the process of just